So, hey there, everybody. This is our first episode of the Nurse and Doc Roundtable, episode one. And I am Dr. Casey Peevler, and this is my friend Jordan, and he's going to introduce himself and let us know why he is here with us today.
Well, thank you for having me. Jordan, I'm a registered nurse here in Florida, and we're here to discuss functional medicine and mitochondrial DNA. Well, that's what I understand.
Understood. So, what I think my understanding is we're going to have a diverse, subset of topics that we can kind of discuss. I think we want to at least kind of address the information that's presented in the corresponding week, potential questions or issues, or maybe things that I didn't explain very well, that I can potentially try to salvage the explanation and do a better job of teaching. And then there just could be random questions. I think ultimately we'd like to have even like the audience post Q&As or like kind of post questions throughout the week, and then we can answer some of those questions in a more kind of like relaxed and open format. So anyways, just of note, Jordan actually worked for Integrative Functional Medicine for a good, what do you think? Was it a year and a half or maybe even longer than that?
Yeah, two years. It was all of COVID, so that's
Right. Prior to you
two
becoming a
for
nurse
COVID, and
while you were
yeah,
there.
so I was there the entire pandemic, pre-pandemic, post-pandemic.
And you asked
So
questions regularly about health related topics, and we've had some pretty good discussions. I know that right now we're really into EMF, and I hope that we can talk a little bit about that today. But anyway, so what were the questions that you came up with, looking at the content that's posted so far? I know we kind of talked about either the sun and disease video or possibly the mitochondrial heteroplasmy videos. I'm not sure which episodes that you, I don't know, didn't make sense or had questions about.
yeah.
So what were the questions that you come up with?
So I did find the mitochondrial heteroplasmy videos pretty interesting. And I think there's a lot of practical value for the general public here, both clinicians and, patients looking to help their conditions. Um, first, just for the general viewers, heteroplasmy is like mitochondrial damage, right? Is that a simple
Mitochondrial
definition we can?
DNA damage. Mitochondrial DNA, as we kind of talked about, like there's many copies of this circular DNA inside of mitochondria, and every mitochondria is going to have DNA that is at some different level of heteroplasmy, right? So, because the majority of the redox of the body goes on inside of the mitochondria, the electron transport chain, et cetera, there's a big opportunity for a lot of reactive oxygen species, reactive nitrogen species to then damage the mitochondrial DNA. And when that happens, it can be catastrophic for the mitochondria, because the mitochondrial proteins that are responsible for electron transport chain are encoded on that mitochondrial DNA. There's 37 genes, 13 of them code for mitochondrial electron transport chain proteins, cytochrome proteins, et cetera. So yeah, it's the damage of the DNA. Now it will then, because the mitochondrial genes are not expressed correctly, or they're damaged, they can't assemble, then that will create further damage. It's kind of a feed forward loop where then maybe, let's just say hypothetically, cytochrome 1 is now more leaky of reactive oxygen species. You're going to have more ROS, more oxidative stress, more DNA damage, and that could become catastrophic at some point. So yeah.
Yeah, and given that a lot of diseases are at the core is tied to mitochondrial heteroplasmy, should one care, or should it be a question if there's mitochondrial heteroplasmy, if one is ill or dealing with any kind of disease, or should just be clear, okay, this is mitochondrial heteroplasmy?
So we know that mitochondria develop heteroplasmy, and under normal circumstances, normal aging, you develop, they say something about 10% of, there's a 10% higher mitochondrial heteroplasmy per year, or per decade, excuse me. So we know that's the portion of like how we are finite on the earth. You know what I mean? Like we develop mitochondrial heteroplasmy, the mitochondria become more leaky and more susceptible to oxidative stress and then downstream inflammation. So there's always a degree of heteroplasmy going on for even people who are not sick. But the people who are sick and prematurely sick definitely will have a higher degree of mitochondrial heteroplasmy in different tissues. And that can kind of explain the complexity of mitochondrial disease, because you may have heteroplasmy in your liver or your lungs or your brain, and I may have it in my heart and my vessels and other places, or my kidneys or something like that, right?
And that 10% heteroplasmy that you mentioned, that's for healthy individuals per decade. Um, we reside in the States, given that like I think it's like 70% of the population's overweight or obese. Is that a realistic number for our population, or is it probably worse?
Well, the issue is that we can't measure directly mitochondrial heteroplasmy clinically. Like, it's measured in the lab, you know what I mean, by PhDs and researchers, you know what I mean, in a research setting. So therefore, like, we have no good test, I can't just like order Quest, like, hey, mitochondrial heteroplasmy, you know what I mean? I can't, unfortunately, I can't order that. And so it's very safe to assume that if a person has developed diabetes or has developed high blood pressure, has developed obesity, has developed cancer, they are at varying levels of mitochondrial heteroplasmy. But unfortunately, there's no way to measure it outside of the bench research kind of setting.
Got it. There's varying levels of mitochondrial heteroplasmy, and depending where it's more concentrated, if it's at the liver, brain, heart, that's where the disease will manifest itself. So if it's in the heart, like heart disease, brain, neural degenerative disease, is that how we can say it works?
That's my understanding of it as of right now. Yes.
Okay. So then, is there a way now that we can go ahead and find out what is causing that? So if it's heart, brain, could it be excessive ROS, oxidation, or problems with calcium homeostasis?
So, exactly. Like, those are all great points, right? And so obviously, how do I say this? Like, I think I alluded to in one of the later videos that, we're only like 82 slides into a 1200 slide PowerPoint that I've created, right? So the goal of what we're doing now is just to like give the background information to understand like what these processes are, so then we can go into the detail of how it actually happens, right? But yes, I mean, to cut to the end, like, yeah, I mean, inflammation, toxins, oxidative stress, what I would consider the four horsemen of disease, are basically what damage mitochondria. But because mitochondria are where the redox centers are at, it's a lot of times the most basic or fundamental cause is a redox imbalance. And that can be caused by several things, but it can just be internal redox imbalance. You know what I mean? So we'll talk about that in detail, about how that develops and what systems you have in place to mitigate that or to protect you from that. But yes, it's very safe to say that oxidative stress leads to this problem.
And is there, now that you say that, we're talking about the mitochondria, in, I guess we could say in our experience, we know that in functional medicine, there's a focus on seeing the body as a whole in different systems, but it's not very common to see a direct focus on the mitochondria. Should one cut to the chase maybe as a clinician, or should a patient look for someone who, a clinician, a provider that's knowledgeable with the mitochondria? Is there a difference between, let's say, treating, looking at, okay, you have high levels of inflammation, oxidation, insulin resistance, or just looking at straight to the mitochondria? Is there a difference between those approaches?
Yeah, I hear what you're saying. I think that, in functional medicine, we aren't supposed to be looking at the systems so separated, like in conventional medicine, where it's like my cardiologist only looks at my heart and my vessels, and that's it, right? Or, my neurologist only looks at my brain, or my gastroenterologist only looks at my GI tract, right? Or my nephrologist only looks at my kidneys. In functional medicine, it's supposed to be more comprehensive and systems-based, approach that is, it's not just one thing, a holistic, however you want to, derive it. And we are trying to look for the root causes. And so, there's a classic slide that I like to show patients, and that's that slide of like the symptoms, and the organ dysfunction, and then the what I would consider the four horsemen, the real true drivers of the disease. But how those drivers manifest and how it gets created is by the quote unquote root causes, right? So yes, I mean, we should be looking at all those things, and it's kind of synonymous. If you have a bunch of excess inflammation and oxidative stress, it's synonymous basically with mitochondrial dysfunction, right? Because they're the things that are the most susceptible to environmental factors that are those processes are driving, right? And then on top of that, if there's, unfortunately, it's like a snowball effect, because once you have some inflammation, insulin resistance, oxidative stress, that will damage the mitochondria. The mitochondria, when they become dysfunctional, they start to be the main problem of creating reactive oxygen species and driving inflammation. So it is, I mean, I do think that, to distill your question down, should the clinicians be looking at mitochondrial function as a fundamental driver of disease? Absolutely. Should the clinician be versed in how to look at those factors and how to determine mitochondrial function? Absolutely. And do I think functional medicine, I was trained by the IFM, the Institute of Functional Medicine. We have an entire module on energy. At least when I went through it, it was called energy, the energy module, and it was 3 days basically dedicated to kind of mitochondrial issues. And I don't think it goes deep enough, if you want me to be honest with you. I mean, I think that in retrospect, what seems deep at the time is actually pretty superficial. I think it's a good start. I think it's a good kind of like, appetizer, but the clinician, I mean, the patient and the clinician should go as deep as possible to figure out where these issues are coming from. And the list of root cause or root causes should be exhaustive, because it can be sometimes very overt, you know what I mean? Or sometimes it can be very difficult to find, you know what I mean? Especially in terms of your light exposure, your circadian rhythm, your EMF exposure, et cetera. Those are things that it's very difficult for the average person and average clinician to measure without going and doing a home survey and looking at the light environment, looking at, detailed kind of analysis of the patient's sleep-wake cycle, but also their home and whether or not they're under a lot of either magnetic, electric, or radio frequency fields, you know what I mean? And having the proper tools to evaluate that. Yeah.
So there's typically, when you go to a functional medicine provider, as I understand, correct me if I'm wrong, after an evaluation assessment, you'll receive something maybe like okay, you have gut problems, let's have a gut program, an adrenal program, whatever it may be. Is there a difference between now those and, let's just do a mitochondrial program? Would that tackle all of those? Is that all encompassing? Can we think of it like that?
It's a great question, Jordan. I mean, I think that, the style of practice is going to vary from clinician to clinician. Even within functional medicine, I mean, one of the things that I don't like about the IFM is that it gives you a lot of information. I don't think in some areas, I don't think enough, but it gives you a lot of information about functional medicine and kind of the approach that you take, but it doesn't have a very obvious, like, stepwise approach about how you would to do workups and treatment. It's just kind of like, here's a module about detoxification. Here's a module about functional gastroenterology. Here's a module about functional cardiology. Go practice, you know what I mean? And I think there's a real lack of guidance and mentorship about the process, which is kind of, I think, what led Dr. Kalish, right, to create the Kalish Institute and have a mentorship. And I'm so grateful that I went through that, your mentorship. I mean, do I think Dr. Kalish goes deep enough? No, I don't. But at least it gives you a framework, a blueprint of like how his mentors have been doing that using functional medicine practice for a long time. Kind of zooming out a little bit, I still think that since mitochondria and the four horsemen that damage mitochondria are the fundamental factors of drivers of disease, I think it would be short-sighted to address other issues without addressing that first, or at least trying to evaluate whether that's a major problem. And as you know, as the person who for 2 years ordered the labs for me, through the, asking the patients to give you their information and order the labs. And, I know you and I have gone over several labs together and what it means. And I think it's
What an
fair to
experience.
say that it's pervasive, right? It's not like, I can't say that I've ever had anybody like come back, who, even people who are quote unquote healthy, like have issues, what I mean? They have mitochondrial dysfunction. They have the underlying drivers of the disease. Now, if they're healthy, maybe those drivers are not as extreme as some of the people who are already sick, right? Because there are extreme examples of people who are really like have a lot of multi-system function or dysfunction, I should say. But yeah, I don't know if that helps. Does that help?
Yeah, I mean, it makes sense that one should focus on the mitochondria instead of like tackling other issues that really are at the core are mitochondria based. That's what I have understood.
Yeah, I think going back to like Jack Cruz, you and I both follow Jack, and he's brilliant, and I consider him a mentor. Uh, I'm not at his level, I can't understand everything he talks about, and I try, to follow that. But I think that, yeah, energetics within the cell determine the cell's fate. If you can't make ATP, or if you can't power the enzymes and power the system, you're in bad shape. So I think it's not a good place to start. In these other, if someone comes in with GI dysfunction, it could still be mitochondrial problems. If someone comes in with hormonal imbalances or different things like that, it still could be mitochondrial in origin. Because it's so fundamental. That should be the first place we look, and it should be addressed at definitely first. I do believe.
Yeah, that makes a lot of sense, and glad you pointed that out. Would it be a wise idea? I know in some research they look at something called ATP to ADP ratio. Would that be a good practical test to have done or employ?
Right. Yeah, we don't have that test clinically. That's again another one of those research things. Um, ATP is made on demand. The flux of the cell and what's demanded, and so I think it would be, it's one of those things like, how do I say it? Like people come in right to the hospital, and it's like, oh, my heart rate's 95, and it's like, well, yeah, or your blood pressure is 150, and it's like, yeah, but like it's something that changes on a second to second basis. Depending on the state of the person, right? If I'm acutely anxious or I'm in a lot of pain, like my heart rate's going to go up, my blood pressure's going to go up. And if I sleep, my blood pressure's going to go down and my heart rate goes down, and that's supposed to happen. And that's going to be the same thing with mitochondria. They are going to be putting out more energy, generally during the day, and they're going to be more in kind of a repair and mechanism at night. And there's a circadian flow to a lot of these cellular processes too. I found some really cool graphs, as a matter of fact, about how like antioxidants are more active during this time of the day and they're not as active during this time of day, or whatnot, because there's different processes going on when you're conscious and when you're moving around and you need to do things.
That's a really good point. Now that you brought it up, brings to mind a question. Something that I used to know is that circadian biology, it's like tied to like a lot of our diseases, like 80, 90%. But so is mitochondria. What's the connection between both of them?
Well, it may be a little bit higher of a discussion for this particular episode, because I think we have a lot of information to lay down before we're able to talk about that. But just, it's needless to say, it is intimately involved, right? Because there are hormones that are released. I think melatonin is one of the most, it's one of the most unbelievable substances your body can make, and melatonin is directly related to mitochondrial performance. It's a driver of mitophagy, the recycling of mitochondria, and it's the recycling of mitochondria that keeps the damaged, diseased, high heteroplasmic mitochondria from taking over and going out of control, right? So it's directly tied to each other. Circadian and mitochondria are they go hand in hand.
Great. And that makes sense. So now it's not like we're talking about two different things. Like this is circadian biology. And this is now mitochondrial biology. They're intimately tied.
All the same. And then the other end of the coin is vitamin D, right? Vitamin D has its own mitochondrial actions, whether it be acting on the antioxidant systems, whether it be acting on the electron transport chain, whether it be signaling genes to improve mitochondrial redox performance, etc. And that's a hormone that is obviously created under sunlight. You know what I mean? So that's the other end of the spectrum. There's the dark and night cycles, and there's some really neat diagrams that I have in my PowerPoint from studies that illustrate this quite well, I think. So we can talk about that, later.
And before we wrap up, can we say, based on melatonin being so important for mitochondrial function, should sleep be the #1 health priority, like over everything else, like diet, exercise, what else, other facets of health? Would sleep be a #1?
Yeah, that's a tough question, man. I mean, because it's hard to underscore the importance of sleep. And there's sleep, and then there's sleep, and then there's sleep, right? Like, obviously, I can go to sleep.
We all know that, right?
Right now, like right now, I mean, I'm working a night shift, and it's awful for me. And I'm going to sleep during the day tomorrow. That's bad. You know what I mean? If I was to sleep, without being protected from EMF, that would be bad. You know what I mean? If I was to sleep and not be in a cool environment, that could be bad. If I'm sleeping and I'm not protected from sound or from light, that can be bad. You know what I mean? So like there's sleep, and there's different qualities of sleep. And definitely the more high quality restorative sleep that you can get, I think definitely the better is going to be for you. You know what I mean? At the right times too, right? So to make sure that your mitochondria are being recycled and your hormones are being released at the right times, because it's all light driven.
Man, I think that's really interesting. I know we're probably extended for this episode, right?
Yeah.
But I have a host of different questions.
That's cool, man. We're going to try to do this weekly. I think that there's a lot of good discussions. I mean, and even though I think the core of these discussions will be me and you talking about these things, I think we can bring on other guests, in other fields of integrative and holistic health, and get their opinion. I even have, obviously, like being a conventional doctor, I have a lot of conventional buddies, and who I could have them give their, impressions of the state of the health system or whatnot, or their maybe their questions about integrative or functional medicine, quantum biology, et cetera, too. So yeah. So I guess we'll sign off from here. Thank you for coming, and thank you for attending our first Nerds in a Doc roundtable. And until next time.
Till next time.
See you later, Jordan.